Hi, a warm welcome to you all today. Hello, good morning, Ron from Jennings. What are you wearing?
All geared up to become an engineer, sir.
Get going. Good. Today, we will be discussing the subject of strength of materials, and we will be dealing with the Unit 1, which basically describes the fundamentals of strength of materials.
Strength of materials seems to be interesting and very important concept.
As the title goes, strength and materials are the two words around which we will proceed with our discussion.
But what materials are we talking about, sir?
The different materials used in the various engineering applications, the civil engineering discipline in particular, are like historically the bricks from clay and later the building blocks made of cement concrete and the subsequent developments that resulted into the reinforced cement concrete and glass, which is used for the various partitions and facades.
Thank you, sir.
Then we have structures which are made from steel, especially in the industrial environment, where we need large spans of unsupported systems. Understanding these basic materials, we now try to focus on the requirements of strength of these materials. There are 6 basic types of strength that the materials are subjected to. One is tension, then compression, then bending, followed by torsion, shear associated with bending, and then impact, stroke, vibration. The strength against impact, stroke, vibration is not common, but the others, what we see here in the list, are most common strengths required by the different materials. I will now give you example of a press which is used in the printing industry, a simple press called the Brahma's press model, where all these forms of strength are easily understandable in the system of the structure of the press. The press has a horizontal top arm and it has a central shaft. The shaft is having a flywheel, then it has some screw threading, then you have a bottom plate.
That looks like a massive screw with a lever attached to it.
We have 2 vertical legs to support the top arm. The plate below the central shaft will have the material to be compressed beneath it. Then you have a base of the whole system, which the 2 vertical legs are connected. If you try to understand the behavior of this system, when the central shaft rotates by the use of the flywheel, the so-called rotation arrangement on the top, the flywheel, then the shaft moves downwards and applies what is called compression on the material below the shaft. In turn, the base try to react upwards to the compression offered by the material. If you look at the material tries to react internally to the compression in the form of opposite forces, similarly on the base also. Thus, if we look at the reaction of the material onto the frame, there is an upward force which you see here, which is transmitted through the central vertical post, and it is transmitted to the top arm in the form of
What kind of load is acting on the arm, sir?
a transverse load to the axis of the top arm. This transverse load will cause what is called bending, and the top arm will be a bending member. The reaction from the material which is under compression will be pushing the central shaft upwards, and in turn the top arm is subjected to a transverse load. The two side posts will resist this upward force in the form of tension. These two are subjected to tension inward. The end posts are tension members. Then we have the flywheel and central shaft above the top arm. This part, if we observe the force system, when the wheel rotates perpendicular to the axis of the shaft, trying to offer a downward movement, which in turn tries to apply a downward force on the screw thread system, and the screw thread tries to resist this moment by friction in the opposite direction. Thus, the shaft above the top arm is subjected to what is called torsion. This region of the shaft is subjected to torsion. It is a torsion member. This force, which is a rotational force perpendicular to the axis of the shaft, is called torsion. So, just to brief about the first four requirements of strength by the system, we have the compression, which is the strength requirement of the material which is being pressed. In simple literal terms, that is pressing, resistance to pressing. Then the tension to which the end posts are subjected to is the resistance to pulling or pull, resistance to pull. Then the top arm, which is subjected to transverse load perpendicular to the axis of the top arm, and it is subjected to bending, that is resistance to bend. In literal words also, it is resistance to bend. The last one, which is torsion, is a requirement which is a resistance to twist.
Twist? I do get that. And it's called torsion.
To understand the shear, we will go for a simple example in the form of the joint of two plates. Now, if we take two steel plates which are connected by a bolt system, the two plates are pulled in opposite direction, and the section of the bolt which is at the common contact surface is subjected to forces in opposite direction, which is called shear. The bolt is subjected to opposite forces at the section which is the common contact surface. This type of behavior or resistance to sliding is called shear. The last one, impact or vibration, is a phenomenon which is mostly observed in the case of moving loads, like the beams of a railway bridge or a road bridge, then beams supporting the machinery like a turbo generator of a power plant, these are the different examples where you come across vertically downward forces which will be like a sudden drop of a load onto the beam. As you know, the wheels of a railway wagon, there will be a slight jumping during the motion of the train. It is because of the bending of the beam which will be trying to lower the wheel, and then the elastic backlash, you can say, that is a reversal of the behavior of the beam against bending, which will try to come back to its original position, is what is resulting into a sudden impact by the wheel onto the top of the beam. So these kind of repetitive sudden impacts will result into what is called vibration. If it is slow or an intermittent fall of the load onto the beam, it is called impact. Impact is an intermittent falling load, and vibration is continuous or rapid falling load. So these are the different examples to which the various structures like the buildings, like the bridges, etc., are subjected to by the different types of external forces that will be requiring the strength of the material against these different forces.
Could there be combinations of these strengths, sir?
Ron, good question.
The complexity of the strength of materials lies in the combination of these various strengths. A member may be subjected to a combination of tension and bending. I'll give the example of a roof truss where the bottom member will be carrying at different locations by small wires false ceiling of the building. This is false ceiling. This is roof truss. This entire thing is the building. This bottom member, due to the loads, it acts, this entire truss acts as a beam under bending because it is subjected to lots of lateral or transverse forces due to the roof load, due to any people walking on the roof or cleaning the roof, like the dead and live loads, we call it the self weights of the stress system, and any other additional loads like people walking are called live loads. Because of these vertical gravity loads which are transverse to the axis of the system, because of that this truss will be behaving like a bending member, like what you see in the top arm, and the bottom chord of this truss will be under tension because the truss will deform like that. So this is pulled and this is compressed. The whole system tries to bend like that, because of which there is a pure tension in the member. In addition, you are also having some loads because of the false ceiling, which are again transverse to this. So this member is subjected to combined tension and bending.
I have seen such buildings before, and now I get all that goes in there.
So like that, we have different combinations of any of these four, that is compression and bending, tension and bending, alternate compression and tension. I will give you an example of a vertical tower like any antenna tower, which is having the antenna on top, and there is a load which is reversible wind on the system. So because of that, when wind applies on this tower in this fashion, there is a compression that happens first to resist, and then there is a tension in the bracing system. This is an antenna tower. This is the antenna. When rather wind load is applied on this system, then the tendency is always to resist the load in tension where the material is very strong. It tries to utilize tension as much as possible. So the tendency will be first, there is a direct connectivity with the antenna by the top member. Top member has to be inevitably in compression because wind is applied like this. This member in turn transmits by tension. Then again there will be a compression on this. Then again there will be a tension. Like this, the members are subjected to, all the diagonal members are subjected to tension when wind is applied in this direction. When wind is applied in the opposite direction, the other diagonal members will become effective in tension. So like that, a member is changed from a zero tension to maximum tension condition when wind is applied in different directions.
Zero tension to maximum tension. Interesting.
The same system, if you have a different bracing condition, this is called cross bracing, this is called A type bracing, because the shape is something like letter A. So in this bracing, when the load is applied, there is compression here and then there is tension here, but there is compression here also that parallelly occurs, because there are two parts of the top member. This particular situation of tension and compression will reverse when you have wind from this direction. So in this case, you see that a member which is normally supposed to be very effective in tension will also have to act as a compression member. So like that, a combination or reversal of role, all these things are possible in the case of various structural members, and you will come across different combinations of the four basic strengths called the tension, the compression, the bending and the torsion.
And each material could act differently with these four, right, sir?
We understood that there are different materials and each material has got certain requirements of strength. Now, which material is suitable for which particular application is what is the next part, where a decision has to be made based on the strength of materials knowledge. All brittle materials like the clay bricks, RCC blocks and glass, they are all good in compression but very weak in tension.
A brave man acknowledges the strength of others.
Similarly, all elastic materials or metallic materials like steel, aluminum, etc., they are very good in tension and they have certain limitations in the compression because of the economic viability of the material, because those materials are costly, almost 6 to 7 times costlier than the brittle materials which are available today. That's why a material which is of common nature to take both the compression and tension could be derived, and that is where the engineers have evolved what is called reinforced concrete.
I never knew so much goes to a simple system like this.